Stacks are everywhere, even when you don't see them. Today we'll cover what a stack actually is, the 4 operations that define it, where stacks show up in real software, a classic algorithm, checking balanced parentheses, and finally, when a stack is the right tool for the job. A stack is a collection that follows one strict rule: last in, first out. Think of a stack of plates. You add to the top, you remove from the top, and that's it. No reaching into the middle. The newest item is always the first one to leave. Here the right end is the top. That's where every push and every pop happens. There are only 4 operations you really need. Push adds an item to the top. Pop removes and returns the top item. Peek looks at the top without removing it. And is empty tells you if there's anything left. All 4 run in constant time. O of 1. That's the magic of a stack. You don't pay for the size of the collection, just for the operation itself. Stacks are quietly running the systems you use every day. Every function call your program makes lives on the call stack. That's why infinite recursion gives a stack overflow. Undo and your editor pops the last action off a stack. Your browser's back button is a stack of pages. Compilers use stacks to evaluate expressions and check syntax. Depth-first search through a graph or tree is just a stack pretending to be an algorithm. In Python, a stack is just a list. You don't need anything fancy. List append is push, list pop with no argument removes from the end. But if you want the contract explicit, here's a clean wrapper. The 4 methods are the entire public surface. That's it. Stacks are simple by design. The discipline comes from how you use them, not how they're built. Here's the classic interview problem. Given a string of brackets, are they balanced? The trick is a stack. Walk through the string. Every opening bracket gets pushed. Every closing bracket has to match the top of the stack. If it doesn't, the string isn't balanced. At the end, the stack should be empty. Linear time, constant extra space per character. The same pattern shows up in syntax highlighting and JSON parsing. When should you reach for a stack? Use 1 whenever you need last and first out behavior. Undo, backtracking, expression evaluation. Use 1 when you need to remember and reverse a sequence. Use 1 to convert recursion into iteration. Avoid stacks when you need any position access. That's an array or a deque. And avoid them when the order you want is first in, first out. That's a queue, which we'll cover next. Stacks are deceptively simple, but they're one of the most useful data structures you'll ever learn. Once you spot the LIFO pattern, you'll start seeing it everywhere in your editor, your browser, even in how your code runs. Next up, queues. Same idea, but the other end. First in, first out, and they have their own clever tricks.